Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about Cisco Safe. Specifically, we're going to do an overview of Cisco Safe, and then we will talk about securing the individual modules of the enterprise campus. So let's begin. The Cisco Safe, or Security Architecture for the Enterprise, blueprint provides to network and security designers guidelines for implementing security mechanisms for the Cisco campus design. The SAFE blueprint follows the enterprise composite network modular approach presented throughout this entire video series. All of the SAFE strategies are applied to each module and component of the enterprise architecture model's design. From a network design standpoint, the SAFE blueprint is a security architecture that covers the following aspects: attack mitigation policy, enterprise-wide deployment, secure reporting and management, authentication and authorization, IDS, and ongoing support for emerging technology. The policy for attack mitigation ensures that possible attacks and threats to the organization can be identified and defines the countermeasures that will be used against those attacks. The SAFE blueprint is usually applied in an enterprise-wide deployment, not just to an isolated component. It also provides methods and mechanisms for ensuring that the reporting, management, and auditing are accomplished in a secure fashion. It includes secure authentication and authorization with strong encryption and digital signing techniques, including public key infrastructure, PKI. It also includes intrusion detection services for critical resources and networks. The SAFE blueprint provides ongoing support from Cisco for all the emerging technologies it provides. The SAFE blueprint allows you to apply a systematic approach to security from a modular standpoint. Risk at the Internet connectivity block would include the following: reconnaissance tools, port scanning tools, IP mapping tools, mail relay, distributed denial of service, and malware, including malicious code, viruses, Trojan horses, and worms. In order to secure the Internet connectivity block, the SAFE blueprint recommends the use of firewalls, router access lists, and network IDS to mitigate the risks presented already. You should also consider hardening the network devices and servers in that particular block. You can also build DMZ networks to isolate specific devices from the network infrastructure. For many organizations, the e-commerce block may get its Internet connectivity through the Internet connectivity block, or it may have its own connections to an ISP. Regardless of this aspect, the risks and guidelines for the e-commerce block are very similar to the Internet connectivity block recommendations. According to the SAFE blueprint, in this block you should protect high-profile e-commerce servers, as this is where you will also encounter the defacing of web services technique. The e-commerce block is also vulnerable to denial of service and distributed denial of service attacks. Countermeasures in the e-commerce block involve using access lists, filtering, and firewalls that protect the database, applications, or transaction servers. The servers should be hardened by using only the necessary applications and ports. Ensure that the e-commerce applications are secure by frequently updating and patching them. Cisco IDS should also be used, and the e-commerce block should be placed into a dedicated DMZ zone to isolate it from other blocks of the network. The VPN and remote access block is often connected through the Internet connectivity block to various Internet service providers, so you should use common techniques for securing it. However, because you will be using VPN technologies, some unique security mechanisms can be implemented. Because remote access and VPN networks often use the public Internet or PSTN as their carrier, you should be aware of possible spoofing techniques that will allow an attacker to impersonate a legitimate client and get remote access or VPN access to the enterprise network. The network becomes vulnerable to spoofing if the attacker is able to steal credentials or guess the authentication key. In order to secure the remote access block, you should carefully implement VPN technologies using dedicated equipment, which includes advanced security mechanisms. You can use the IPsec protocol to assure proper authentication, authorization, and encryption, and IDS and firewall equipment can be used as well. In order to secure the WAN block, according to the SAFE blueprint, VPN techniques are used to ensure point-to-point secure connections. You should also use strong cryptography methods such as triple DES or AES to provide the confidentiality and integrity of the data packets. In addition, use authentication with all the WAN peers and harden the WAN routers to ensure that only the necessary protocols and ports are used. Additional security measures including using filtering techniques based on Cisco access lists and on network devices. The network management submodule must be secured, and it's especially vulnerable to inside attacks. The written security policy should describe the procedures that apply to this submodule, and a best practice is using AAA services. These are usually based on Radius or TACX servers that will provide authentication. Other possible problems might involve administrator impersonation for individuals who might want to get administrative level privileges that will provide them access to all the other blocks in the Enterprise Campus module. In order to mitigate these threats, you should use strong encryption techniques and SSH instead of Telnet for remote administration. In the server farm block, the main goal is to protect the servers using strong and secure operating systems and applications. The servers should be periodically verified to ensure that they have all the proper updates and patches and that they are hardened. The server farm block can include firewall policies that will assure proper access control, as well as switch ACLs that will only allow certain traffic to flow at the data link layer. IDS should also be used in this block to ensure connectivity to other campus blocks. The access layer block is the place where the end hosts and the lower end access switches are located. In order to secure them, you should use HIDS technologies, in addition to the standard hardening techniques, which will only allow the necessary application, services, and ports to run. If the access layer block also includes complex IP telephony integration, special measures must be taken to secure the VoIP infrastructure. So here's what you've learned. You've received an overview of Cisco SAFE, and then you've learned about securing the individual modules of the Enterprise Campus. All of this information you will definitely need to know for your CCDA exam. Good luck in your studies.